Hey, greetings and welcome to this edition of the GradientOne video demonstration series. Today, I'm going to walk through one example that highlights three specific things. One, how you can control multiple instruments using the GradientOne test automation framework. Two, how GradientOne sends commands to the devices. And then three, the type of data that's collected when an instrument's commands are processed and the data is stored on the cloud and made available for engineers after the test. Okay, so first things first. We have this lab in Northern California that has two instruments that are currently online. I happen to be in San Francisco. This lab is in the Tahoe area. I have a RIGOL scope and a Tektronix MDO3000 scope, which also has a function generator. So what I want to do is I want to have the function generator send a signal to channel 4 of the RIGOL scope. So first things first, let's take a look at the status of the RIGOL scope and see what's happening. I just clicked the Fetch Screenshot button. The Fetch Screenshot button is an example of an abstracted command set that we have provided for engineers. So instead of having to crack the manual and figure out the right type of kind of LXI, SCPI commands, etc., to get the right screenshot, we've done all that for you, and it's standard across all the instruments we support. So all you have to do is click Fetch Screenshot for either the Tektronix scope or the RIGOL scope, and you will get the same result as an engineer. So let's go ahead and right-click, open this in another browser tab. So now what we're doing is we're going to the results library, and we're seeing this specific screenshot that we just acquired. And what you'll see is channels 1, 2, and 4 are disabled, and channel 3 is enabled, and it has a UART signal processing on it. So what we want to do in this case is we want to disable channels 1, 2, and 3, enable channel 4, and get it ready to acquire a signal. So what we've done here is we have a configurations library where we have previously run tests that we can use and reload in a consistent manner across all the different devices of that particular product family. So this setup works for the RIGOL 1000 scopes, and it's an example of the case where we have specific SCPI commands being sent down to the instrument to accomplish what we want. So we have channels 1, 2, and 3 disabled, channel 4 enabled, we set up the trigger, and adjusted the scales, etc. So let's go ahead and load this to the instrument that we want to control. You can select that based off the online available instruments. This is what we saw in the library. Yep, that looks good. Let's run get data. It will now process those commands, and looks like everything was done successfully. Great. Now let's go back and program the Tektronix scope. So in this particular case, what we want to do is we want to enable the signal let's start here. We want to enable the signal generator. So what we'll do is we will write AFG auto output state on, add that to the queue, hit get data. Great, looks good. And now if you go back to the RIGOL scope, what we're going to do in this case is we want to configure it to run, make sure it's ready to receive, and if all goes well, then we should see a waveform, sine wave, that is representative of the output that's coming from the Tektronix MDO3000. So what we'll do is we'll send the get screenshot command, and great. Channels 1, 2, and 3 are disabled. Channel 4 is enabled with the sine wave. Okay, so that's kind of a highlight of how you control multiple instruments and the types of commands you can send. But one thing that's worth highlighting is, you can, besides grabbing just the screenshot, GradientOne can actually acquire the waveform itself. So in this particular case, we're going to go ahead and acquire the waveform, the screenshot, and all the settings of that particular RIGOL scope. So what it's doing is it is interrogating that system, it's getting all the settings, it's actually getting the specific waveform that we were just looking at, and it isn't just the screenshot, it is actually the times and voltages that are represented there. And just to kind of give you some proof of what I'm talking about, we will click points, which shows the raw data that was sampled by that particular scope acquisition. So we can actually zoom in, and you can see those are the points themselves. And if you want to go back to line mode, you can do that. And that's where we've kind of connected that line for you. Let's go ahead and reset view. All this data is interactable. We have a tooltip so you can see the times and voltages. And this is all very handy for post-processing of data. If you want to do a bunch of tests and do some analysis really quickly, instead of having to do some more sophisticated programming and maybe you're trying to get this data, parse it in a Python script or something else, all that can be done available in our online platform. And one of the things that's very handy is you can use the scope shot to do the comparison to make sure that what you acquired was what you saw on the scope. So reset view, yep, that's exactly what we thought it'd be. Here's the metadata, instrument serial number, a variety of parameters, time-based scale, number of data points that were required, as well as all of the voltages and time measurements that you wanted for that particular trace. So that's all for now. I hope this is helpful. 3 things we covered: controlling multiple instruments, the types of commands you can process, whether they're abstracted commands or skippy commands, and then a deep dive into the type of data that you can acquire using GradientOne. Hope this is helpful. Stay tuned for more. We'll see you soon. Thanks.